All right, moving on in chapter 2, we're going to talk more about these molecules and compounds. So we've talked about how there are several atoms or an atom with certain characteristics that make up elements. And when we combine these elements, we form what's known as molecules. And so these atoms or elements combine with other atoms or elements to form the molecules, and then the molecules can form compounds. So a molecule can be considered two or more atoms that are bonded together. So two hydrogen ions put together or bonded together is a molecule. C6H12O6 is glucose, so it's several atoms that are bonded together. A compound is going to be where you have two or more different kinds of atoms bonded together. So in this case, our glucose, C6H12O6, actually has three different atoms or elements bonded together. So that's going to be a compound. You start to get a mixture of these. So let's take a moment to look at chemical bonds. If you remember, what I talked about briefly in lecture is that the chemical bonds are storing our energy. That is how energy can be stored, and as a biological organism, that's how we store our energy. So chemical bonds are a relationship of energy between electrons of atoms. So again, the electrons, if you remember, exist in these little shells, or we call them shells, but they exist around the nucleus, around those protons and neutrons. And there can be up to 7 of these shells, as we call. And they're essentially, you can think of them as circles. So here is the nucleus, and you can see in this example, we have 3 circles around the nucleus. Each circle is called a shell. The first shell will always have only 2 electrons in it, orbiting, if you will, around the nucleus. The second shell, third shell, those start to go up in numbers. The second shell will have 8 electrons. The third shell will have 18 electrons. And each shell can only hold a certain number of electrons. Okay, we always fill the first shell first. So the first shell will always have 2 electrons unless it's, say, hydrogen, which only has 1 electron. The second shell will hold no more than 8, and the third shell will hold no more than 18 electrons. This begins to create what we call the octet rule. So all of the shells, except for the first shell, are going to have 8 electrons in their outermost energy level, okay? Or what we also call this is the valence shell. So what we're saying here is that even though the third shell I just told you can hold a maximum of 18 electrons, in order to be a relatively happy or stable atom, it needs at least 8 in its third shell. And again, these electrons are going to fill these shells in order of first, second, third. You wouldn't put, a couple of electrons in the third shell and only have 6 electrons in the second shell. It fills up in order of shell. So first shell gets filled first, second shell gets filled second. And an element is, or an atom is happiest when it's got a valence shell or 8 electrons in its outer region. We have some of these elements that are very stable with the number of electrons that they have, and we call these chemically inert. They're stable. They're not going to readily react. And they're also known as the noble gases, so they just don't react. Their outermost shell or energy level is fully occupied or contains 8 electrons. Again, that first shell can only contain 2 electrons, and that is helium. So helium is actually one of the noble gases because it's very stable. Its outer shell has its max capacity of 2 electrons. So it's a happy camper. Neon is another stable or noble gas because it only has 2 shells, but its second shell or outer shell is perfectly happy. It's got its 8 electrons, so it's perfectly content. And so all of the elements on the right-hand side of the periodic table are going to be these elements that are noble gases, or content because their outer shell is completely full.